चलिए दोस्तों शुरू करते हैं without wasting a time. Today, today in this video we'll discuss about the segment routing in case of multi-domain, and we'll also see how to configure BGP prefix SID. And this is the lab we have where we are running L3VPN with the multi-domain. So I have a two domain ISS core 1 and ISS core 2. ISS core 1 domain is running with the BGP AS1 and ISS core domain 2 is running with the BGP AS2. And in all both of the domains, all the routers we are using is segment routing, and segment routing global block size is same 16,000 to 17,000. And I have mentioned the prefixes of each device. As we have seen in the last video also, we are using the prefixed index number is same. Index number is the loopback address 4th octet. So like here we have on the PE1, loopback address is 100.100.100.100. So we are using a prefixed index 4th octet. 4th octet is 100. So this means index will be prefixed for this PE1 will be 16,000 is the base range plus index 100, 16,100. And here we are I've already configured the ISS core 1 and BGP, all of the config already there in both of the BGP ASs. And I have also showing the couple of output with respect to data plane when we are trying to reach the from PE1 to PE2 loopback 0 and customer route. And as we can see that here we are running a BGP VPN V4. If we talk about the VPN V4 path, BGP VPN V4 unicast family is running P1 to RR1 and then RR1 to RR2, RR2 to PE2. And we are running BGP LU for exchanging the prefixed and label unicast path end to end. For this, PE1 is running with the BGP LU with the RR also and with this ASBR. Between this ASBR1 and ASBR2, we are running a eBGP, and this is again the BGP label unicast. And between the ASs for this loopback of PE1 and loopback of RR1 and RR2, we are exchanging the prefixed with the help of BGP prefixed. So I will show in the configuration how we can exchange their loopback SID with the help of BGP. Once we have an end-to-end reachability label unicast path in place, we have run this again BGP VPN V4, and with the help of BGP VPN we are exchanging the customer routes. So couple of commands are already pasted here with respect to how the label imposition is happening while we are trying to reach from the P1 to P2, loopback to loopback, and from the customer network to customer network. So let's jump to the CLI. Let's log into the PE1 and verify a couple of commands for the label imposition happening to SEF and in the BGP table. So here we are on our first router, the provider Edge 1 router. So let's quickly check the showrun first. Protocol file, let's check first. Showrun router ASRs. Okay, so here it is. So we are running in this ISS domain core 1, and we have enabled the segment routing MPLS in the ISS, and on the loopback we have given the prefixed index 100 as for this PE loopback address is 100.100.100.100. So this 4th octet we have considered as a index number here. Okay, so on segment routing, this is here we have defined the global block for the segment routing. This is the range for the label 16,000 to 17,000. Let's verify now customer VRF configuration. This is the VRF we have configured, VRF blue here. Okay, loopback 100, and this loopback we are calling in the VRF blue. We can consider this is the customer prefix. Let's verify now BGP configuration. BGP router BGP AS number 1 is running here. and here we are driving the BGP our loop back with the help of network statement, and we are attaching the SID value here. This is the loopback IP network, and this is the RPL route policy we're attaching SID 100. Let's verify this. Show RPL route policy. This is SID 100 in route policy name, and what we are doing is set label index 100, again loopback 4th octet. So that label will become the 16,100. Okay. Then after that we are activating a two address family, VPN for unicast, and here we have done the allocate label also, it will become the label unicast. So this is the neighbor IP of our ASBR. Okay, with the ASBR we are only running IP for label unicast, and this is the IP of our RR1. With the RR1 we are running the only VPN V for unicast, and this RR is the route reflector. RR1 is route reflector, and here we are doing the VRF configuration, and we will be doing the redistribute connected. So we have a loop back 100 here. Instead of doing the network statement for advertising the route in the BGP in the VRF route, so we have done the redistribute connected. Let's verify a couple of command now. So MPLS forwarding table. This is the showing the table for the MPLS forwarding table here we are getting. Okay. So let's verify route for the PE2. So PE2 IP address is here we have 100 on the PE2 IP address is 200 200 202. This is the IP address of PE2. So let me verify show self IP v4. If we have to reach this prefix from here, how many labels we are imposing on it. So here we can see this is the Cisco Express forwarding output for this PE2 loopback, which is belong to the AS2, and this route is learning. Here we can see that Joseph, and then via it's coming from 33 33 33. This is the IP address of ASBR1, our ASBR. Okay, and this is a local label, and total label embodiment is 2. Okay, Y2 shift it out, show BGP 200 200. Let me run this command also. So here we can see that what label we are getting. Received label is 16,200. 16,200 is the in the safe command. This is the inner label, this is the BGP label, and this is the label of the next hook. Route we are getting from the ASBR1. This ASBR level is 16,033. The prefix SID for this ASBR1. The two label we are imposing while we are trying to reach PE2 loopback. Let's do the ping MPLS IP v4 200 200 200 200 /32 sources 100 our loopback of IP. Name the trace route also, trace route v4. Okay, so here we are. So this is the inner label BGP label, and this is the prefix SID for the ASBR1. Inner labeling index 16,200 16,200. This reach on the P1, our core router, and here it's reaching on the ASBR, and after that it's reaching on AS2. Okay, so let's similarly verify route in the VRF. Okay, so VRF blue. Okay, let's show route VRF blue. Okay, on this blue VRF we are getting with the help of BGP, we are getting this route. So let's check for this route also itself. Let's verify. Let's take the BGP table first. Show BGP VRF blue. Let me put this here. So this is the customer route we can say in the VRF. And what label, what is the important thing we have to notice here, what is the label we are getting from PE2. So this is the received label. Label is 24002. This label is called VPN label. Okay. And let's check the SEF for this. So SEF VRF blue, and this is the customer prefix. So we are imposing a three label stack in place. This is our VPN label, which you have seen in the BGP table for this. And this is the label for PE2, and this is label for the our ASBR1. As we can see that, so this route is coming from via this next hop. If I take the route for this next hop, this will come from the BGP, and this route is coming from the, so three recursive is happening. This will from the ISIS. VPN V4 route, then BGP route. So here is, so this we can say this is the VPN V4 route. Label is 24002. This next hop is running from a BGP label PE2, and this PE2 prefix we are getting. Next hop will be the our ASBR, and this ASBR in the running from the RSI. Three label stack. Just quickly ping VRF blue, three source 123.123.123. The trace route. Three label stack. Okay. Now, so let's jump to the RR, verify the RR configuration, then we'll go to the ASPR. So here we are on the RR1, AS1. Let's verify the show run router ISS. Again, router ISS core process 1 is there, domain 1 segment routing enabled, and this is the prefix SID, SID index is 100, as the RR IP address is 111.111. Post 111.111, and this is the fourth octet. This is the value we are using in the here index number. This is the global block, same global block we are using in both of the domain. And let's verify BGP configuration. Router BGP1, we are advertising the RR loopback with the SID. This RPL, we are attaching the index. Index number is 111 again from the RR loopback. And here we are defining the two neighbor 3333. This is the IP of ASBR1. We are running address family label unicast, IP for label unicast. And this 100.100 IP address is our PE1. This is our route reflector client PE1, and we are running address family VPN V4. And this is the IP address of our that belong to AS2 RR2. We are running a eBGP with the remote host. From this peering, we will exchanging the customer VPN V4 routes. We are not denying anything. We are using the route policy pass, and when they're doing the next hop unchanged. The fancy here, here we get the route VPN V4 route will in place. I check. These are the route correct for the customer RD 1.1. We are getting these routes from the AS2 from the RR2. So this 1.1.1.12312, this is the customer route belong to our PE1, and this is the customer route belong to, this is coming from PE2, and this is the IP of PE1. So let's jump to the ASBR1. So here we are on the ASBR1. So let me show you the configuration of ASBR1 also. Show run router ISIS. Core 1 process is running. Domain, segment routing and is enabled. Prefix SID index 33 and the loopback IP is 3333. Again, fourth octet we are considering the index number. And this is the segment routing block size. Let's verify BGP configuration here. Router BGP1 label unicast. So this is the neighbor IP of ASBR2. We are running eBGP between ASBR1 and ASBR2, and this is the IP address of our PE1. With the PE1 we are using the label unicast, and this is the IP address of RR1. Okay, nothing fancy here. We can verify, show BGP. There will be no VPN v4 route here as we are not running VPN v4 family here. Okay, so all the route will be the label unicast route. We can see here IPv4 label unicast route. So these are the IPv4 label unicast. You can see these are the loopback 0 IP addresses. So these IP addresses of belong to AS2. So this is IP address of PE2, and this is IP address of RR2, and this is our IP address PE1. This is our IP address RR1. This is the forwarding planes. Let's jump to the core router P1 provider router. So here we are on the provider router P1 router. It belongs to AS1. I'm only going to the show run configuration here. The ISIS. The same thing we are doing the ISIS segment routing enabled, prefix SID index 100, and we have in a loop back is double one. Both octet we have considered as the index number, nothing fancy here. ISS only running, we have enabled the segment routing, that's it. There is no BGP, it's the BGP free 4. Maybe we can verify. That's it. Nothing else. So I have shown you the all of the configuration for the AS1, PE1, ASBR1, router RR1, and provider RUMs. Similar way I have done the configuration for the AS2 also, and we have established and get the reachability using the segment routing in case of multi-domain with the two different ASs, and we have seen how the label imposition, how the data plane forwarding happening when we are sending traffic from one AS to another AS using a segment route. And we have also seen how we have done the BGP prefixed advertisement, how we have done the route policy, how we can do it. Thank you.